For the animation in this module, we're going to be lifting a heavy weight, this barbell, and I want to make sure that when my character strains and lifts this weight, the barbell actually starts to deform and bend under this really kind of cartoony kind of weight that we're trying to create here. Whenever we have a prop that needs to bend and deform and change its shape, of course, we're going to need to create some sort of armature, a control rig that controls that deformation. Naturally, first step, as we've explored before, is creating the physical bones on the inside of the shape. Before we jump into the armature, let's do a real quick kind of analysis, examination of the project file that I provided you. If you look real carefully, I'm going to zip over to the top view by hitting 7. You can see that this shape, this prop, has been perfectly centered in the origin of the scene. It sits at the middle of the x-axis and the y-axis. If we were to zip over to the front view, you can see that right here, down, that's the origin of the scene where the intersection of the blue, the Z, and the red, the X, kind of reside. That's the origin. So the singular pipe that runs down the center of the barbell is not centered along the Z axis. Okay, that's important to remember. And I've done this intentionally. That way, whenever we add this element into the scene, it's always going to look as though it's sitting on the ground, which is pretty cool. The weights of the barbell are never going to be penetrating through the surface of our ground plane, which is going to make it a really easy prop to work with, which is always by design. When we're adding our joints, however, I want to make sure that all the joints are going to be centered around this pipe here, this structure, all of this jazz, okay? And that's going to allow us to facilitate a nice deformation that's even across that pipe itself, that bar, okay? So let's go ahead and start the process of generating the armature. It's relatively straightforward, and we've explored the basic steps before. So in object mode, I'm going to do Shift-A, and then under my mouse cursor, I get this handy-dandy little menu. Let's just go ahead and throw in the armature. Now, with the armature selected, let's cruise over to our object data properties and make one small change to the viewport display properties, and that's going to be in front. With that overlaid on top of all the elements inside of our scene, I can very easily, or much more easily, see exactly where all of my joints are going to be. Let's jump into edit mode by hitting tab, and we can start the construction process of our little armature. I want you to be real mindful of the location of that first joint itself. It's always going to be at the origin of the scene, or actually more precisely, it's always going to be at the location of the 3D cursor, whose default location is the origin of our 3D scene. And that really works well for us in this particular situation. I want the root joint, the parent joint for the entire rig, to be in the center of the mesh, to be in the center of the entirety of the prop itself. The facilitation of the arms kind of bending and all those weights kind of deforming are going to be done through a whole series of separate joints that we're going to start to create now. If you look real carefully here, of course, the screen left side is identical to the screen right side. So the smart way of approaching this would be to create the armature joints for one side and then to mirror them across the x-axis, which I think is always a lot of fun. It's all about working smart, not necessarily hard, especially when we're going to have uniform parts on one side of the mesh that need to match the other side of the mesh. All right, let's jump in. I'm going to use some vertex snapping to help here. Okay. Now, if you think about it, there's going to be a natural place of deformation somewhere around this pipe. Now, do we want it to bend in the center, or do we want it to bend, maybe do we want the start of the bend to happen, I don't know, right around in here? That might be a good thing to kind of consider, because the location of this first joint is going to represent the location where that bend is going to begin. So you kind of have to have a game plan before we go into this. And I think I want to have my axis of deformation happen right about here. I don't want it to bend in the middle. I want to have that center part be kind of relatively flat, then have a bend on either side. Okay. Let's go ahead and do it. I'm going to hit the E key to extrude it out. Now, I'm doing some vertex snapping, and I think this is a great place to go because it's using the verts on the bar itself as a snapping guide. I want to make sure that I'm only transforming that joint along the x-axis. So I'm going to hit the X key to make sure I'm only moving it along the X. And I'm just kind of spot checking here. I'm trying to figure out where I want the bend to happen. Remember, our character is going to grab the middle of the bar, and as the character lifts up the barbell, I want the weights to kind of make this arc, this bow shape, to make it look like it's really heavy. Now, I know that wouldn't actually happen in the real world. This is like a solid steel bar, or I'm envisioning it's a solid steel bar because Pat doesn't go to the gym. Pat does not lift weights. But I'm going to pretend in the cartoon world that it's going to bend right about here. So this is going to be the location of our first joint, somewhere right about there. And I'm pretty happy with that. Now let's extrude out another one. And this is where we're going to change it ever so slightly. I'm going to put another one along the x-axis right there. And let's do another one. I'm going to extrude out another one along the x right about there. And then a last one right over here. Now, if you think about what we're creating here, we're creating zones of rotation. We're always going to be, or only ever going to be able to rotate our bones around the bottom here, this sphere at the bottom. So if you consider that all of these joints in here are never going to rotate much past here, and I think that's exactly what I want. So I'm going to be able to control the rotation between the bar and the weights and the other side right here, and then this part is going to be its own significant chunk, which is pretty cool. That's a good place to begin. Now that we have some joints, get 1, 2, 3, and 4, let's return to our outliner real fast and just take a quick examination as to what we've created. Under the armature itself, we can find all the bones, and the best way to work is to name our bones as we go. Of course, the first bone that we have inside of our entire sequence is going to be the root. Remember, in a hierarchy, we're creating kind of like a tree. The root of the tree is going to be the master controller. Wherever the roots go, all the tree branches are going to go as well. So now we have a whole collection of bones for the left side of our character, and I'm going to put L underscore bone 1. And I'm going to do this on all of them real quickly. That way I can use a handy dandy little built-in tool that will help us separate the naming conventions of the left side of our bone structure from the right side of our bone structure. Remember, working smart, not hard, right? Okay. Now that we have our bones named, let's go and start the process of duplicating them. I'm going to turn off my snapping engine real fast, and while I'm in edit mode, I'm going to select all the bones on this side. I am not selecting the root bone. That's the one thing that's going to remain as is. And now we're going to duplicate them. Shift-D, just like duplicating any other object, okay? Now, before I go any further, I'm going to hit the right mouse button on my mouse. That's not going to delete the duplications, but it is going to delete the transformation. It's going to delete the moving. So right-click. You can see that over here in my outliner, all those duplicate bones have remained inside of our structure. And I want to mirror them across the global x-axis. Now, in order for us to do that, we're going to go up into the Armature pull-down menu. And up at the top here, we have Mirror. We're going to do global X. Now, that's kind of odd, isn't it? Look, it mirrored it over on that side, which is not what I wanted. I wanted it to mirror around the origin of the scene. Well, don't worry. There's one small change that we need to make. If you have the visibility of your 3D cursor turned off, as I often do, go ahead and turn it on real fast and make sure that it's sitting down there at the origin of our three-dimensional scene. If it's not, if it's in a weird location, just do Shift-S. And what we're going to choose is cursor to world origin. That's going to put the cursor, the 3D cursor, in the middle of our scene, which happens to be at the middle of our root bone. Now, the other change that we need to make is inside of our transform orientations. If we go right here, we're going to change the orientation, the pivot point for all tools to be the location of the 3D cursor. Now, when we mirror and choose global X, it's going to use that 3D cursor's location to determine the axis of duplication or the axis of mirroring in this particular situation. And check it out. Now we have our bones in the exact same location as they were on the left side. We have a mirror copy. Now the next thing that we need to do here real quickly, and this is not a difficult thing. I just want to make sure I have them all selected. Now, this is where it starts to get a little confusing because we have two different hierarchies, and this is by design. We have the left side, it's parented to the root bone, and then we have what's going to be the right side, and it's also parented to the root bone. I would love for this to say R, 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 and I'm a lazy guy. I want to work smart, not hard. I don't want to have to go in there and like hand type it. Project this onto a character. If you're trying to change all the naming conventions for all the bones on the right side of the body, that'd be a lot of things to change. But luckily for us, we have an easy tool for us to do this. We're going to go back into that same Armature menu, and under the names category here, there's a choice called Flip Names. And that's going to automatically go in And anytime it sees an L, it's going to change the L to an R. Just a visual way to confirm that our naming conventions for all these bones are consistent, that we can see from the outliner the role and the purpose of the bones on the left side versus the right side, which is pretty cool. Okay. So this is it. This is actually the armature of our system already done. Let's test it real fast. Let's go back into object mode. Just make sure our armature is selected. And I'm going to run into pose mode here real fast because I want to make sure that everything is working the way I want it to work. If you consider the function of this, I want to have one bone in here that I can move. And it's going to move the entirety of the barbell. That's the purpose of that root bone, is that it's going to allow me to move everything. Now my transform pivot points is still set to 3 cursor. I want to put it to active element. That way it's always going to be on the cursor. I'm also going to change my transform orientations to local. There we go. That way it always preserves the rotation of the bone itself. Okay, so the root bone is set. It's working quite beautifully. And what's cool about having this branched system, went into armature, I wanted to go into pose, is now that we have a left side and a right side that are both children's of the root bone itself. The whole idea behind this is that I can bend the left side independently from bending the right side. It gives me a tremendous amount of creative opportunity here to do something fun. Being able to control both sides separately is pretty neat. Okay, it just gives us options. I can see in a situation where maybe we're pulling on one side and not the other, and I want to be able to control that one independently from the side that isn't being pulled. So this is working out great. I'm happy with the bone structure here. We've ensured that they're positioned correctly. We've named them. We've mirrored them. We're ready to start binding this geometry to the mesh and start working with all of our vertex groups.